Hello everyone, it's me again, Alice. Today we're going to talk about one of the building blocks of AI. It's something called machine learning. Imagine sorting laundry. Whites in one basket, colors in another. That's a classification problem. You're using a rule to decide which group something belongs in. Computers can do the same thing, but much faster, and with way more data. That's called machine learning. There are a few big ways machines learn. The first is supervised learning. In supervised learning, we give the computer examples with answers. An example is if we gave the computer a bunch of pictures of dogs and cats. We can tell the computer which images are dogs and which images are cats, and it can learn based on the images we labeled and provided. The next time it sees an image of a dog or a cat, it can use the knowledge it gained to predict which animal it is. This is called a classification problem. Another example of supervised learning is if we work with the computer to come up with a formula to predict something numeric. Like imagine I guess how tall you are going to be based on how tall your parents and grandparents are. This is called a regression. The next type of machine learning is unsupervised learning. Imagine we dumped a bunch of Legos on a table and told the computer to sort them without giving any other direction. It may sort by color, shape, size, or some combination, but it does that on its own without our supervision. That's an unsupervised learning problem. The final example of machine learning is reinforcement learning. Instead of providing examples or letting the computer do its thing, we would sort of train it the way we teach a dog new tricks. After each attempt at solving whatever problem we provide, we either reward or don't reward the computer for the given outcome. Let's take a look at an example. Here we've got two graphs, Zeke on the left and Rowan on the right. Each brick is a Lego set. The x-axis goes from fewer pieces on the left to more pieces on the right. The y-axis goes from younger ages at the bottom to older ages at the top. That's a good clue for how complex the set is. The blue bricks are sets the boys liked. The red bricks are sets they didn't like. Notice something. Neither boy likes the sets for toddlers or sets with very few pieces. Those bricks are mostly red down here. But they're different too. Rowan tends to like more complex sets with more pieces, blue bricks up and to the right. Zeke prefers a middle ground, not tiny, not mega builds. His blue bricks are more in the middle. Now let's use this like a classification model. Can we predict if they'd like a brand new set? Let's introduce a new set, recommended for ages 8 to 10 with 250 pieces. Let's place it on Zeke's chart. That's about here. What do you think? Would Zeke like it? Yes, probably. It lands right where many of Zeke's blue bricks are. Now the same set for Rowan. Assesses in us. Same age and pieces, but look at Rowan's chart. Would Rowan like it? Probably not. For Rowan, most of the blue bricks are bigger and older. This one sits outside his usual like zone. That's classification, using patterns in the examples to predict the new one. This Lego example was pretty easy. We only looked at two things, pieces and age. But in real life, problems have hundreds or even thousands of features. For example, deciding if a plant is healthy might involve leaf color, shape, size, moisture, soil, sunlight, and dozens more factors all at once. That's too much for a human brain to juggle, but it's exactly what machine learning is good at. It can handle many features at the same time to find patterns we'd miss. Machine learning is powerful but not perfect. Sometimes it makes mistakes, and usually those mistakes are caused by how the model was built. One example of how a model might provide incorrect results is called bias. If you only train with certain examples, the computer won't work well on new ones. Another example is called overfitting. If it memorizes instead of learning, it fails on new data. The outcome is usually an overly complex model that finds patterns where no pattern actually exists. The last example for today is fairness. If the training data is unfair, the predictions will be unfair too. That's why engineers have to be careful when building models. So, machine learning is about finding patterns and making predictions. We saw it with Rowan and Zeke's Lego sets, and we'll use the same ideas to help with our project, teaching a computer to tell if a plant is healthy or not. Let's get started.